Hi guys, and welcome to the Tentative Tutor channel. For what integers n is this expression also an integer? 1/5 n to the 5th plus 1/3 n cubed plus 7/15 times n. Shouldn't this always be a fraction? Let's try n equal to 1. Plugging 1 in for n, this is what we get. 1 to the 5th and 1 cubed is 1, so we end up with 1/5 plus 1/3 plus 7/15. Finding a common denominator, this is what we get. And adding the numerators gives us 15 divided by 15, which is 1. And that's an integer. Now let's try n equal to 2. Plugging in 2 for n, we get 2 to the 5th, which is 32, 2 cubed, which is 8, and once again writing them over a common denominator. When we combine this into one fraction and do the arithmetic in the numerator, we'll get 150. And of course, 150 divided by 15 is 10. Another integer. What could be going on? Why is this happening? We'll use Fermat's little theorem. If p is a prime and a is an integer, a to the p is congruent to a, mod p, meaning p must divide a to the p minus a. Here's a couple of examples. For a equal to 2, and p equal to 5, 2 to the 5th is congruent to 2 mod 5. Pause the video and verify that 5 divides 32 minus 2. And also 2 cubed is congruent to 2 mod 3. You can verify that 8 minus 2 is a multiple of 3. And this will generalize to any integer n. That is, n to the 5th is congruent to n mod 5, and n cubed is congruent to mod 3. Now let's look at our original expression. Writing it all over one common denominator, we get 3n to the 5th plus 5n cubed plus 7n. Let's see if we can show that the numerator is always a multiple of 15. So we want to show that 3n to the 5th plus 5n cubed plus 7n is always a multiple of 15. Meaning it's congruent to 0 mod 15. Let's take our original expressions and let's multiply the left one by 3. If 5 divides something, then 15 must divide 3 times that something. And looking on the right, if 3 divides something, then 15 must divide 5 times that something. And we can see that 3n to the 5th and 5n cubed are terms in our expression. So we're going to use these two facts. Let's take the numerator of our fraction and we'll substitute 3n for 3n to the 5th. And we'll substitute 5n for 5n cubed. So we get that the original expression is congruent to 3n plus 5n plus 7n. We can combine like terms to get 15n, meaning 15 will always divide 15n. So that means our original expression, which we wrote as one fraction, has to be an integer because we show the numerator is always divisible by 15. So that mystery is solved. It's never a fraction. It's always a whole number. Thanks for watching.